Hello, my name is Macy Steber. I'm a junior at Holt High School, and my project looked at the effects of vitamin D3 on glucose absorption in Drosophila melanogaster DFDL P1 through 5. Type 1 diabetes is an autoimmune disease that causes the body to attack the insulin-producing beta cells that are located within the pancreas. Over 1.5 million people in the U.S. alone live with type 1 diabetes. Now, a life with type 1 diabetes entails a life of closely monitoring blood sugar levels, accurately counting carbohydrates, and injecting insulin. Now, each day is different, and blood sugar levels are affected by anything from stress, to diet, to exercise, and to so many other things. Now, not maintaining good blood sugar levels could potentially lead to other health problems. New advancements have been made to assist in controlling good blood sugar levels. However, these are relatively expensive and are not readily available to everyone who needs it. Because of this, I aim to find ways that were less expensive and more readily available to everyone. Now, one way that I found was vitamin D. Now, vitamin D is acquired through diet or through sunlight. Tissues have been found to express 1-alpha hydroxylase, and this suggests that vitamin D could potentially act in a paracrine or autocrine manner in an immune environment. Vitamin D deficiency has also been linked to the onset of several autoimmune diseases, such as type 2 diabetes. In a systematic review, they found that vitamin D has been shown to have short-term positive effects on individuals who are newly diagnosed with type 1 diabetes. There's also a study done in Italy where an 8-year-old child was given doses of vitamin D3 and omega-3 fatty acids at the time of their diagnosis. A year later, they were able to maintain good blood sugar levels with only 1.5 to 2 units of insulin per day. Now, I wanted to make this information more applicable to individuals who are not newly diagnosed and who are further along in their disease. So in order to do this, I used Drosophila melanogaster, or fruit flies. Fruit flies share about 60% of their genes with mammals, and this results in similar metabolic and signal transduction pathways, including the insulin signal transduction pathway. Now, flies have hemolymph instead of blood, and in this hemolymph they have insulin-like proteins, which are equal to mammalian insulin. Now, through the deletion of these insulin-like proteins, the fruit flies become a suitable model for type 1 diabetes. So from all this, I pose a question of how will varying levels of vitamin D3 affect glucose absorption in Drosophila DFDL P1 through 5. So it is hoped to be concluded from this project that higher levels of vitamin D3 will increase the efficiency of glucose absorption in type 1 diabetic Drosophila. Now, to look into this, 4 different cultures of fruit flies were set up. The first group was a control group and had no vitamin D supplementation. The second group had 63 microliters of vitamin D, the third 126 microliters, and the fourth 189 microliters. Now, this vitamin D was mixed in with the media that the flies were kept on. After the flies were kept on this diet for 10 days, they were injected with about 1/10 of a microliter of a PBS insulin solution. The flies were then allowed to recover for either 15 or 30 minutes, and after these designated times, they underwent a hemolymph extraction process, which involves poking the flies in the head with a needle, as can be seen, and then squeezing the flies with forceps until a droplet of hemolymph forms on the head. The hemolymph was then collected using a 1 microliter capillary tube. It was then combined with the infinity glucose reagent, and the absorbance was detected at 340 nanometers. From this, a standard curve was created and the glucose concentrations were determined. So as you can see here, these are the glucose concentrations. After a one-way ANOVA test was run, the p-value was found to be greater than 0.05, which ultimately means that my hypothesis is rejected and that my results were most likely due to random chance. However, 2 of my experimental groups suggest that there might be an impact. The group that was supplemented with 63 microliters resulted in lower overall glucose concentrations, as can be seen in the graph. Now, the group that was supplemented with 126 microliters resulted in a decrease of glucose concentrations over time, which was not seen in any other group. However, this might be because the data from this project was based on one trial. It is also possible that the PBS insulin solution does not have a similar effect on the flies as the insulin-like proteins do that the flies already have. It is also possible that the vitamin D could have affected other parts of the fly and could have ultimately made the fly unhealthy. For the future, I would like to conduct more trials to see if my results and observations are repeated. I would also like to conduct trials on wild-type flies to see the effects of vitamin D3 on glucose absorption in non-diabetics. If these are proven to have positive effects, I would like to look into the exact effects of vitamin D on the insulin signal transduction pathway. And finally, I would like to examine and see if the same effects are replicated in humans as was seen in the fruit flies. So overall, this project found that vitamin D3 has the potential to have positive effects on glucose absorption in Drosophila melanogaster DF-DILP 1-5. So I would like to thank the following people: Paula Kiefel from Washington University in St. Louis, Dr. Leslie Pick from the University of Maryland, and Miss Jennifer Hess. Here are my sources. Thank you.